Welcome to Wise Guys Unprompted. I'm Zachary Kreider, joined by my co-host, Martin Holstay. Here we cut through the noise and get real about AI and cybersecurity. No fluff, just insights that matter. Each episode, we break down the latest developments, decode complex topics, and share unfiltered perspectives on how AI is reshaping security. Whether you're a CISO, security professional, or just curious about where technology is headed, we've got you covered. So let's dive in. Welcome back. This is episode 2 of Wise Guys. I know, Martin, you had a busy week with Sonnet 3.7 coming out on Monday this time.
Yeah, didn't spend the whole weekend on it for once, but yeah, it's been quite a week so far getting to know it and just seeing all the amazing things that it can do.
Yeah, and I know you just showed me a website it built for you in like 2 minutes that probably would have taken me a couple weeks, maybe even longer to actually build.
Yeah, well, looking forward to diving into that on one of our upcoming episodes here. But yeah, every week something new, and so you can't forget anything you learned, but you got to add on yet another week's worth of AI knowledge. So glad we're here to do this together and to share our learnings.
Nice. Yeah, and so on this episode, we want to dive really into agentic AI. It's been the big talk now, I think, since probably November-ish timeframe. I think there's a lot of different vendors out there. Obviously, the cloud providers have their own agentic framework. A lot of open source frameworks are out there. And so probably about, I would say 8 months ago, we really started diving deep into agentic frameworks and how they can help us out. So through that, we actually built out a tool that we launched internally, and we called it Sidekick. And so essentially, it really helped us kind of democratize knowledge across the company. Because to build things like maybe a parser for our Helix solution, it was only a small subset of people in the company that were doing that, or you had to find someone in engineering that had time to be able to write the parser for you. And even on the customer side, some people go read documentation, but no one really wants to do that, right? So they would submit support tickets, create kind of a backlog in support, and then that kind of put a burden on engineering. And so we kind of took the approach of, hey, could we solve maybe some of this with AI, specifically agentic AI? And so that's how we came to Sidekick, where we kind of gave it some superpowers. So today it has about 8 different superpowers, all their own agentic frameworks in the back end. And as you'll get to know, Mark and I are not big fans of chatbots, just because you end up spending way too much time going down a rabbit hole with them. So our approach that we took with Sidekick was really kind of form-based. So to build a cloud connector, which is essentially allows our Helix product to connect to a SaaS solution. Traditionally, you'd have to go read the API documentation for the third-party solution you want to integrate with, go write some code, probably take you 3 or 4 days to be able to do that, and testing. And so the way we built the framework is you just give it the API information that you want to include in the connector and click go. And in 5 minutes, you have a fully ready to go production code that you can quickly deploy to your environment. I know, Martin, you have a lot of experience on this. How much time did it take you in the past to be able to write these cloud connectors?
Oh, man. Well, best case scenario, about an hour or 2. And I would always brag about, I'd talk to a customer and then I'd write the plugin on the plane ride home to get it in there. And I'd email them when I get there, say, hey, look how fast it was that we created this plugin for you. Isn't that cool? And they'd be really impressed. And fast forward to now what we're going to show, it's pretty incredible. What I love most about it is it's another example of us using AI not for AI's sake. It's what business problems do we have? What are we trying to get done around here? And then sure enough, AI can help us do that versus, hey, what kind of science fair project can I, get someone interested in, right? We're really looking at it as a business approach first, which is where are our longest to-do lists, right? What's the low-hanging fruit here for the boring work that we don't have time to do and nobody wants to do? Let's have something take care of that.
And you bring a good point. No one really likes writing parsers. If anyone's been in a security operations team, parsers was not in your top 10 list of things you enjoy doing. So anything you can pass over to AI to do, software engineers are more than willing to give that up to AI to actually write those.
Yeah, that's been easily the most the least favorite task, I guess what I'm trying to say, for any of them. I've never met anyone that liked writing a parser, but the list just keeps growing and you don't, get rid of them because, we've seen plenty of software that's 15, 20 years old out there generating things like logs that we need to parse or, understanding connectors, those kinds of things. So this has been a really great application of that.
Yeah, and too, like we get a lot of questions of, hey, did you just go train a model to do this? And we didn't actually train a model to do this. The approach that we took is, if you look at a software engineer organization, you're going to have a business analyst that kind of gathers the requirements, puts it together for a development team. They'll go write the code based on their schema and format. They'll hand it over to QA. They'll test it, pass it back and forth, and then go to production. So that's how we built out our agentic framework. And when really looking at what information to give the agentic framework, we took the whole approach to, if we were to onboard a new engineer to be able to write parsers, what information would we give them? Documentation, good code examples, and that's essentially what we're using as few shots within the agentic framework to actually quickly build these out. So we didn't have to spend a lot of time cleaning data, training a model. We were able to quickly build out a framework and then provide information that we already had readily available, and we're kind of off and running with that approach, which has been huge for us because it's been a huge time saver and be able to crank out all these different agentic frameworks to do different tasks in the company.
Yeah, and plus we get to take advantage of the latest models as soon as they come out. So 3.7 this week, much better coder than previous versions. Great. So now we have that ability too. We have to wait and train our models and get them all, on board. It's we could take the best of both worlds.
Yep. Yeah. And so today we have a special guest. So we'll go ahead and introduce Harrison Ahearn. So Harrison's the man that's been doing all the magic with all the agentic AI in the back end for Sidekick and making it work. So why don't you introduce yourself, Harrison?
Yeah, hey guys. Happy to be here. I started working at Trellix, I think about 8 or 9 months ago. I think 9 months next week. I graduated from Tufts. I'm computer science, so I have a big coding background. And I think I dove in pretty much day one of how can we solve business tasks using AI and how can we do it agentically rather than training models, because training models is quite difficult. Writing agents is considerably easier.
Yeah, so you bring a good point. You started, right? And we kind of pushed you off the deep end pretty quickly, but you're able to swim pretty well, right? And pick up the agentic framework. So being right out of college, like how did you take on working with large language models and agentic AI? Because it was new to you, right? When you kind of started?
Yeah, so I think ChatGPT kind of hit the, kind of like made mainstream, I think my senior year or my junior year. So it's such new technology that no one really has a full grasp of it. In any sort of like expert level, I think, except the guys actually making it. So for me, a lot of it was just learning, Python libraries that actually use it and experimenting, using it day to day, figuring out what works, figuring out what doesn't. There's no guidebook you can read on how to best use AI, because I don't think anyone really knows, and I don't think we're not going to know, and we're not going to know for a few years till there's much more data on it. So a lot of it's just experimenting, figuring out what works. And a lot of it was data-driven development. So Langsmith, which is a tool that we use, you can do what are called experiments, where you have inputs and outputs, and you can see if I'm getting better results over time. So that helps, but there's really only so much that you can do.
That's a good point, right? So we looked at a lot of different agentic frameworks that are out there of, vendor provided or other open source. And, I know we really honed in on LangChain. So how easy was it really to pick up LangChain, just be able to understand how they go about building out their agentic frameworks and then leveraging their tool set?
That's a good question. So I think their tool set in general isn't that complicated, and learning about these different libraries isn't too complicated. It's more about learning how to actually build something that's good, I guess. Because, Python's not a wicked complicated language. A lot of the stuff that we're doing coding wise isn't that technically complicated, but it's more about making something that is good at what it does, uses the LLM wisely, doesn't cost too much, doesn't require too much back-end data manipulation that's going to make us drive up costs. So a lot more of the problem solving is spent there than about, I think, the coding and about understanding the frameworks.
Nice. And you took advantage of the LangChain Academy, right? A lot of examples they had that really help you kind of get up to speed much faster and learn some of the different techniques that they have?
Yeah, so not necessarily LangChain Academy, because I think that came out, like a month or two after I really started all this and had to familiarize myself with it. More by looking at their, they had a lot of GitHub examples where they talked about, here's this paper, this research paper that someone wrote on an agent. Here's our implementation of it in LangGraph. So that was really helpful to see, okay, there are actually, maybe not experts in the sense of a lot of typical fields, but there are some experts. There are some people who seem to know what they're talking about. and they've made these new implementations. They've seen these results. They have real data showing why their methodology is effective. And LangGraph actually says they've implemented it, and here's how you can do it. So that was really helpful to experiment quickly, because there already were examples out there.
Nice.
What would you say is the biggest time saver with something like LangGraph over doing it natively?
It's just all the built-in support. So I don't have to figure out how to build a React agent. I can just call the React agent from the library for me. I think if you were teaching this in school again, you would make a student build a React agent for good learning. But in this context, we don't really care too much about if it's done quote unquote the right way. We care more that it's doing the job we ask it to do. So LangGraph really allows you to do that well, but also gives you a lot of low-level control of the components. That's pretty helpful as well.
Gotcha.
And how's it been working with the different models, right? Because I know a lot of time when you write code, right, usually you get stuck into a specific model or vendor. Like, how's it been to be able to change different models with the agentic frameworks that you built out?
So I think because we're starting to lean more into data-driven development, and because we're using Bedrock, which has so many different models to choose from, we're able to pick and choose which model we want for which task. So it's very helpful it's just very cool that we can choose the best and most brightest model, have it run a job, get a score for it, and then say, well, this costs this much. What if we did it with a smaller model? Would it perform significantly worse, or would it still perform 95% as well, but cost half as much? So for Claude specifically, we use Sonnet a lot, but Haiku for some jobs is as effective. So why wouldn't we use Haiku when it costs half as much?
Yeah, we were just talking about that last week on the actual security decisions being made, but what you're talking about is a whole other slew of decisions. So there's code generation, right? And then you want to talk about some of the other use cases. Is it primarily code generation? There's templating too, and things like that, right?
Yeah, so we started with code generation because there was a lot of backlog for different integrations with our products. So that's where we started. We quickly went into, I think it was kind of RAG style agents after that, then into, now we're into reflection lately. So I feel like we're kind of going around the whole, we're kind of experimenting with kind of all these techniques, seeing which one works, seeing which works in different subject areas.
Gotcha. Have you hit any snags on anything, or come across any specific problems you had to overcome with some of these models, and you work around them, or how do you detect right away if you're on the right model?
That's a good question. So I think in general, a lot of times it's just about the basics, just about, are you prompt engineering correctly? So even if you are finding that a model isn't performing where you want, that can usually be fixed by prompt engineering. There are times when it can't, and that's because the problem you're doing might just be too complicated. It might be something that that model isn't built for. It's not smart enough, I guess, would be an interesting way of saying it. It's not smart enough to handle that kind of task. So that takes some engineering on, what are we putting in its context window? Are we filling up its context window too much? Are we giving it too many examples to the point where it can't focus on the correct details? Are we giving it not good enough feedback? Could I change the feedback so that it has a more informed decision? So oftentimes it isn't just swap out the model for a bigger model, you'll get better results. It can be, and that is the case. But there's a lot you can do even with less powerful models by having smart prompt engineering, by having smart context window management.
Yeah, we were just talking about that last week as well, but it's such a different context. We're talking about code generation than the things we were talking about last week with reading in data and making essentially reading comprehension decisions on it. Two totally different use cases, but I think that is kind of, we try to look for anything that's the same in this industry week to week, right? Everything moves so quickly. It's like, okay, this is one fundamental concept that we can at least start to focus on, which is how do you make sure that it's looking at the right pieces of data? So I think your point about not confusing it with too many examples, I think is a really good one that I've seen, at least for the last year, be a theme across models, which is that you can't give it too many examples where it gets confused and it'll start to just default to the last thing, even on large models like Claude. And I've seen 3.7 do that a little bit this week as well. It's been better for the most part, but I think kind of learning those tips and tricks seem to be a little bit more perennial versus some of the more nuanced things where you have to figure out what prompt engineering for this particular model looks like.
Yeah, Mark brings a good point, and you talked about too. I think most people, when they've experimented with coding, right, it's going to ChatGPT or something of that nature and saying, "Hey, write me a full-blown application." Usually, it times out once it gets to 50, 100 lines. Like, what's the largest application you've seen so far that the agentic AI has been able to write, and like, how did you kind of overcome that?
Yeah, so we started with what are called SOAR plugins, which we might talk a little bit more about later. And those can be anywhere from a few hundred lines to 1,000 or 2,000 lines. Obviously, I think even now, but certainly at the time, this was I think 6 or 7 months ago, and things are changing that quickly. The models really couldn't handle anything above 300 lines, and this was solved largely by chunking up the code base. So we know that this function can be written by a model very easily. But these 10 functions probably can't be written by the same model easily. So a lot of that was, can we make a hierarchical system where we're delegating different functions and different pieces of the code base to different models with different context windows. So that was one way we solved it, but that was one way we kind of thought about that problem. Another one was with Helix integrations. Those ones, they're typically smaller, only in the order of a few hundred lines. But they can be quite varied because there's some Helix integrations that run asynchronously, some that don't, some that pull, some that are webhooks. But each of those are comparatively simple, just varied. So we didn't want to give 10 examples of 10 different types of integration to one model. That would jam up the context window. Instead, we have kind of like a front LLM before the problem that says, here's these 10 types of integration, and here's this requirement spec. Which integration type do you think would best fit here? And that way we can give it relevant examples. So it's not just about finding all the examples, but finding the most relevant examples. So there's a lot of really cool engineering in the details, I think, of a lot of this stuff, is what I noticed.
That technique's a great point. So if you try to say, hey, read this entire code base and then accomplish these tasks, that's way too much, right? Even now, even with like 3.7 that just came out this week, still can't do that. But if you organize it a little bit more, piecemeal, where you say, okay, first do this, then and Zach and I were just talking about this earlier with the context window. Does it, the whole conversation is part of that context window. It starts to get bigger and bigger and bigger, unless you can refresh it for each kind of module that you're working on. So having the, a monolithic files can be problematic, but as long as you've got smaller files, it can do smaller file operations. But I think just breaking it into those steps, like you said, I think is one of the key components that I imagine this will still be needed even, a few months from now and probably a few years from now. I mean, there's always going to be some limitation, and just that kind of technique of saying, all right, first we're going to scope what needs to be done. Then we'll have a narrow in on this area and what's the smallest amount of example that we can give it. And then, how do we test that and going on from there?
Yeah, I think also a useful bit of information is that you can always have a static system prompt. I found that's been really helpful too. Just kind of to set the character that you want the LLM to embody. So it's useful for it to know we're working on this type of integration across all 10 submodules. So having a system prompt also is another layer of uniformity across the context windows. So you can kind of enforce that and then change everything around that. It's been helpful as well.
I think the other thing this really emphasizes is the importance of having that kind of plug-in structure where you can have sort of atomic software architectures, right? Where you can say, in order to accomplish this task, you don't have to know how it connects to a backend database or any of that stuff. You can focus on just what is that agentic component, just what does it have to worry about that's external, what's new, and then everything else is abstracted internally. If your software is already set up for that, then you're going to be in really good shape. And we were really lucky like that. So for Cloud Connect specifically, I mean, it runs on AWS, but none of the specific plugins have any idea that they're running on AWS. They don't know they're running in a Lambda. They don't know that the backend's SaaS or whatever. All they know is they're supposed to go out to an API and then do something in the info and then yield that in a loop. And as long as you got it in that kind of style, then sure, the AI can spit that out much more quickly, as opposed to read through this huge framework and understand how to do it, right?
No, totally. I think it's interesting that the very thing that we're doing to help our developers have an easier life, which is making these smart software systems, also helps AI. Like it applies both ways. So I think it's interesting.
Yeah, absolutely.
Cool. So you have an example I think you want to show and kind of walk through what it kind of looks like.
Sure thing. So this is really cool. This is a Langsmith Studio or LangChain Studio. It's made by LangChain. It's like a cool front end for agents that we're developing, so we can look at how they're running in tests. Which parts of the code are being interacted with to kind of get the control flow down. So I love this page. I spend way too much time here. But so this one that I want to show you today it's our syslog parsing agent. So syslog logs are what a lot of our developers spend way too much time writing parsing rules for, and these parsing rules are quite complicated and extremely tedious because they have to be correct down to the character. So this is an agent that I made that can do that automatically, do that for you. So let's start it up. Actually, I think I'm going to start it this way. Let's fork so we can see how it works. So essentially, I've given it a log, and I'm telling it, here's the log. I want you to make a parsing rule for this. It then generates an initial rule. It does all this reasoning, not hugely important, but it is doing a lot of reasoning, a lot of chain of thought, a lot of stuff like that. And it makes a rule. This rule is not correct. It's not smart enough to make it correctly on the first try, but it is smart enough to get pretty close. So we then give it to an edit rule step, and we say, here's the rule that you've written. Here's an output from a testing framework that we've written. It's not correct. Can you find the flaw, and can you make a correct rule? And it will try. It will probably fail again. But after 3 or 4 of these tries, it eventually gets it correct, which it just has here. And now we go into some final output steps and some final formatting steps that aren't really important for the demonstration. But the crucial part of the demonstration is just these 2 reflection steps of let's write a rule, let's edit it, let's talk about why it's wrong, let's reason through why it's wrong. I'll give you 5 chances. If you can't get it in 5 chances, we're going to start over and make a new init rule step. So this is what's called a reflection agent, REFLEXION, so a reflection agent. And that's how this one works. This is just one example of an architecture. We've worked with like a ton of different architectures, and they all kind of serve different purposes. I think reflection is really strong for when you have like a known correct answer. Like for parsing this exact log, there's a definite known correct answer. You want to know this IP address, you want to know this IP address, you want to know that it was a TCP port scan. Like these are things that absolutely have to be captured by any parsing rule you write. So it's really simple just to make a test for that and say, did you get that stuff out of the parsing rule you've written? So that's why reflection works great in this scenario.
So not as good at writing screenplays. This is going to be a little bit more handy for the templated work.
Mm-hmm, exactly.
Nice. And like what's the speed that it takes to be able to write this, and like how many logs have you thrown at this to kind of see how it's able to turn through those events?
We must be at a million. We must be in the millions at this point of stuff we've tested with this. The speed of it, so it's pretty much as you saw for this log, which is on the smaller side. Only a few really key bits of information it ran in basically a minute's time. For some of the longer ones, it can run for much longer, and we give it more loops. So we allow it kind of more chances when the log is much bigger, because that's obviously much harder for it to get right on the first try. But we've done tests with 20,000 logs, I think is typical for a test, where we'll say, here's 20,000 logs, write a rule for the first one, see how many logs the first rule you've written gets correct, as in these are repeats, take those out of the queue and keep going and keep iterating. And that can yield, I think in the order of hundreds of parsers. A single parser can take a human, tens of minutes to write perfectly, write correctly, write specific enough. This can write it in a minute, and it can do it for hundreds and hundreds. So it's a huge increase in efficiency, and it takes time, or it gives time back to our developers. Our developers aren't doing this tedious work anymore. They're doing much more cool things that our customers really care about, and we can offload this kind of mental labor onto AI.
Well, and critically, that's the kind of thing that we have every new customer we bring on has some new data we haven't seen before. And so this is something we need to be able to scale with, the growth in customers, is to be able to say, we don't have to have a n number of staff per customers. This is more like a login situation where we have that automation in place to make sure that we're not going to get overwhelmed by, we've got 20 new customers this month, so they'll have these requirements, and oops, we got too many at the same time. It's going to take forever to get all their logs parsed, whatever. And now this is something that I think has been a really big point of satisfaction for customers to see that kind of quick turnaround.
Exactly.
You originally did parsers, right, when you started. So like, how long did it take you when you were writing those manually, looking at logs manually in a spreadsheet, trying to figure out what to parse?
Oh man, that takes me way back. I've probably been writing those parsers. I've probably read the first one 14 years ago, maybe 15 years ago. It's syslog NG. It's good, which still has a fantastic engine for doing the pattern matching. But it's incredibly terse, detailed work where every character matters, and it's just the kind of stuff that humans are the absolute worst at. So I wish we had this 15 years ago. It would have saved me many, many late hours going through all of this. And I probably personally wrote, I don't know, 1,000 plus parsers easily through the open source stuff that I did and things, through the company. So it's, many people will be very happy about this.
Nice. And Harrison, I don't know, do you want to actually show what Sidekick looks like and throw in a parser in, how we made it not a chat bot and an easy user experience?
Yeah, sure thing.
And I think that loop there that verifies things, I think, is really that key, that it's not just, oh, hey, we used AI to figure out what the parser is going to be and then hope for the best. It's an enterprise grade system where it's got that full test unit around it.
Yeah, this is right. This is what, your third iteration, or probably like 100th iteration of how this framework should look like. Because Martin brings up a good point. I know originally when this was built out, it was kind of just a straight shot, like it didn't actually reflect. So what was like the quality when it was just kind of a straight shot versus when you added reflection? Like, what was the gains that you saw?
Yeah. So I think this is basically my millionth iteration of this. Yeah, when we first built it, and I think the one that's still on Sidekick today is just a one shot. And that it's like shockingly accurate in the sense that, it does, like, I see what you've tried to do. I see that there's, these characters you forgot about, or you kind of misunderstood how this type of rule works. It's not how it works, but I kind of get why you did that. Which isn't scalable. If you have to go through every single possible, or every single thing that it outputs and recheck it over and over and over again just to get one, you can't scale that to something that you can give to, or that you can deploy across all of our customers. So by adding in this reflection step, which required a custom test bed with really good debug output, I saw results immediately. I remember when I first kind of built in the reflection framework, I didn't know if it was going to work because I knew that the one shot wasn't all that effective. It was effective that it would give you a starting point, but not effective in the sense that it would do it for you. So I made the test bed. I kind of plugged it into this framework, and I expected it to not work. I expected to have to come back the next day because I did it as like the last thing I did that day, and it was like right in 2 tries. And I was like, oh my god, we might really have something that can save a lot of people a lot of time. This is amazing. So that was like an awesome moment. Seeing how effective reflection was.
You bring up a really important point that I think a lot of people arrive at, which is the difference between proof of concept and something that's delivering something of value, right? And everyone gets their moment of amazement when it's like, wow, Gen AI can do stuff that I never imagined possible, but it's like, okay, but back to work, right? And then this is where it's like, no, actually, this is just accomplishing work on your behalf because of that test framework, because of that reflection capability. It's not just saying, oh yeah, wasn't that a cool little shiny thing that happened? It's no, this actually just knocked out these tickets for you.
Exactly. Yeah.
Cool. Yeah. So you want to walk us through Sidekick and what it looks like from a user standpoint?
Sure. So let me go to the homepage. So this is Sidekick. We have, I think, on anywhere from like 8 to 12 agents, depending on what you want to call a different agent, because there's like sub agents and stuff like that. So this has taken at least 7 months to make to get to where it is now. I think we basically started it on my day one. But there's these categories of different agents we have. So we have integrations agents. Those write the Helix and the SOAR plugin integrations that I talked about earlier. We have scripting agents. So scripting agents are those are RAG agents. Those are we have a YAML, a giant YAML file, comb through it, find relevant pieces of information based on a consultant or a customer question, and then make useful code out of that. That's what those are. We have a security framework which can do research. If you give it URLs, we can give it like an actual topic to search from and say, here's this latest like news. So when DeepSeek came out, I gave it like DeepSeek news articles and said, what are like the cybersecurity ramifications of this? And it came back with like 5 more URLs I hadn't even bothered to look at. And it said, here's a summary of them. Here's what the US government says about it. It was really cool. We have some stuff for our sales people. So we have a 10K reporter agent. That one essentially works by, you can give it different stock tickers, and it will actually read the latest financial reports on those stocks in the Edgar database, in the SEC database, and it will summarize it, and it will not only summarize it, which is like a very typical task of AI, it will then look at the summary it's produced, pick a few key topics that it thinks you want to know more about, and then do research on that by Googling and finding websites and finding relevant data. So that one's really cool. So yeah, we have agents that are really doing everything. I think a lot of this is just we're trying to figure out what works the best and what do people like the most. But even so, I think pretty much all of these have business use, even if it's not like the most in-your-face business use, like I think the parsing is. So this is.
I feel like each one of those plugins is like a Y Combinator right there. Like you got like all of Y Combinator right there. Like each one of those is, oh yeah, here's our VC-backed business idea, and it's like, oh yeah, we just messed around and threw this out in like a week.
Totally. Let's see. Try to get some output for the database ever loads. So I broke Zach's no chatbot rule. Really sorry about that. But for this one, I thought it'd be pretty useful. So I asked it, how can I perform case management of threats in Python using our EPO SaaS APIs? It then said, I found these documents in the document database that I gave it, and here's relevant Python. And then because the intended user of this might not be like an engineer, it might be like a consultant who can program but isn't like the best programmer ever, lives in terminal. It also throws in some useful instructions and some like how to test to verify its output. So that's a bit of like tailoring to the intended user.
Nice.
Yeah, that's awesome.
Cool. No, thanks, Harrison. Thanks for jumping on today and really diving into this. I know a lot of people will be interested, right? So I'll say, if you have questions about this, definitely throw something in the comments or reach out to us. We're always happy to jump on a call with you and talk through how we're solving this, right? It doesn't necessarily have to be, Trellix solution focused. We can talk through like how we're leveraging AI from a security standpoint, how we're helping to speed up even internal development and internal tasks leveraging AI.
Yeah, thanks for having me.
Yep, thanks for coming. All right, we'll see you all next time.
See you next time.